Hi, everybody. This is lesson 13 from Unit 4, Exponential and Logarithmic Functions. So what we have right now is the interest formulas that you're supposed to know. I put them, this is the original one, your initial amount or your principal. If you have a growth rate that is like 2 or 3 or 1/2, and your exponent, which would be your time. Now, here's when we moved into percents, where we said, okay, here's the initial amount or the principal, and it's 1 plus or minus the rate, whether we are growing, earning, or decaying, depreciating over time in years. Then we moved into, well, what happens if we compound monthly or quarterly? And that was when we now have 1 plus. Now, remember, when you're compounding, you're doing something more than once a year, so you're always going to be a plus. And this would be the number of times per year. And then we have to have the number of times per year up here as well. Then we get to what happens when we compound continuously. Well, compounding continuously, we call this the PERT formula, where the amount over time is the principal or the initial amount, E, which is Euler's number on your calculator, raised up to the rate times the time, and that's in the exponent. So, using these, let's go through this packet. All right, we're going to start, and I'm going to be writing with the mouse, so it might not be as neat as normal, but let's see what happens. A person invests $100 in an account that earns a nominal yearly interest rate of 4%. Now, we say nominal because if we compound the interest once a year, we would use the 4%. But we don't always do it that way, as you recall. But let's start with part A. How much would this investment be worth in 10 years if the compounding frequency was once per year? So now we're talking once per year. And if this were to happen, we would say, okay, the amount, whoa, I cannot write with the mouse too well. The amount over 10 years would be the $500, because that's the initial amount, times 100% of your money. You're keeping that 100%, but now you're getting the 4% each year for all 10 years. So you type that into your calculator, and you end up with having $740.12. Then it says part B. If, on the other hand, the interest applied 4 times per year, so now we're compounding quarterly, all right? And if I'm going to compound quarterly, then I have to go back to this right here where we're saying, okay, the rate is 4 times over the whole year, but I'm now going to do it 4 times. So I'm not going to do 4% each quarter. I am actually going to do here where I would say my amount over time and now I am going to have my $500 and then I would use the 1 plus the 4% divided by 4, which would give me 0.01. So at the end of the first quarter, I only had 1% increase, and then at the end of the second quarter, I'd have another 1% increase, and at the end of the next quarter, another 1% increase. And then at the final quarter, the last 0.01%, 0.01%, and then we would do this. If for a year, we would do it 4 times for every year. And that's why we would be using this now. So if we did this, what was my growth rate? My growth rate now would be 1.01. Like I just said, you would get 1% per quarter. So that would be 0.01. And we would do this 4 times a year. And then we would come over to here now, and we would say, okay, so then how much am I going to have in 10 years? Well, in 10 years, the amount back to 10 years over 10 years, we would have the $500 and we would have the 1.04 per quarter, 1.01 per quarter, and we did this 4 times a year for all 10 years. Type this in, you are going to see that if we compound quarterly, we have $744 and 43 cents. Which, look at it, from here, compounding once a year to compounding 4 times a year, we made more money. Only $4, but it's only been 10 years and it's only a 4% interest rate. So you just have to pay attention to that. You do make more money compounding. Now, when higher interest rates and compounding more often, you're going to make a whole lot more money. So how much would $1,000 invested at a 2% interest rate compounded monthly? Now, this is going back to all those big problems we had on the exponent test where we were talking about car loans and mortgage payments. So we would have here the amount in 20 years would be the $1,000. And then this would be your 1 plus your 0.02% compounded every month, which is 12 months in a year. And now we're going to raise this up to 12 months in a year times 20 years, which would also be 240. And we're going to hit enter in our calculator, and we are going to get choice 2. I'm not even going to try to write all those numbers with the mouse. So type that in and make sure you get that. So overall, here's the formula again. What do they want? So instead of initial amount, they want you to use principal. So here we go. Here's our principal times our 1 for 100% of what we had, plus the interest rate we're being charged. Whoa, that's a really bad. Let me just get rid of that and try that R again. The interest rate divided by the number of times I'm compounding, raised up to the number of times the time. So if we now go to the next page and we look at some of these other problems, it wants to know, number 4, an investment with a nominal rate of 5% compounded differently, give the effective yearly rate for the frequencies. So if I was going to get 5% compounded quarterly, that would be 0.05 divided by 4 times a year. So this would now give me an effective rate my growth rate now in my problem would be 1.0125, because that's what I would get. If I type this in, I'd get 0.0125, add that to my 0.1, yikes. And then that would be raised up to 4 times a year times the 1 year. So my effective amount that I would be getting per quarter would be 0.05 0924. So if I want to talk about what percent am I getting over the course of a year, really, with compounding, I'm going to get effectively 5.09% if I compound quarterly. So I actually get more than 5%. Now let's talk about what happens with monthly. Well, monthly, it would be my 5% divided by 12. So you do that on your calculator, and that now gives us an effective interest rate of 1.00417, raised up to, again, now 12 times a year for this 1 year. This gives me an effective interest rate, or effective growth rate rather, of 1.05116. So roughly, here's my 5%, but it's really 5.116, so 5.1%. Per year. So again, they say it's 5%, but if I compound 12 times, I'm really getting 5.1%. Daily, now you definitely need a calculator. You have your 5%, and there are 365 days in a year. And so this gives me now a growth rate of, now this looks really small, 0.00137. But again, now you're raising it up to 365 times for this year. So 365 times 1. And now I end up with 1.05126. Which would be 5.13% for the year. So if you look, quarterly, you get 0.09%. Yearly, you get 5.12% if you do it monthly. And daily, you get 5.13. So it constantly grows. And lastly, the PERT, which is continuous, which I told you is the scariest thing out there because it is continual. It never stops. If it's your credit card, it's very scary. But here, you're going to put it in a bank. $350 at 2% continuously would look like the amount over time and here's your initial 350 and now your E and your rate is 0.02 multiplied by the time. So you can put a multiplication in your exponent. So if you now then put 20 years in